6 complex predicates. In order to further understand the translations that appear in the previous sections, and in order to be prepared for more complex translations still, we now examine the notion of complex predicate. Roughly, complex predicates stand to simple ordinary predicates as complex molecular formulas stand to simple atomic formulas. Like ordinary predicates, complex predicates have places. There are one place, two place, etc., complex predicates. However, we are going to concentrate exclusively on one-place complex predicates. The notion of a complex one-place predicate depends on the notion of a free occurrence of a variable. This is discussed in detail in an appendix. Briefly, an occurrence of a variable in a formula is bound if it falls inside the scope of a quantifier governing that variable. Otherwise, the occurrence is free. Examples: 1f(x), the one and only occurrence of x, is free. 2x(f(x), gx), all three occurrences of x are bound by x. 3x or xy, every occurrence of x is bound. The one and only occurrence of y is free. Next, to say that a variable, say, x is free in a formula f is to say that at least one occurrence of x is free in f. On the other hand, to say that x is bound in f is to say that no occurrence of x is free in f. For example, in the following formulas, x is free, but y is bound. f1y or xy, f2y or xy, f3y rix, f4y rix. Any formula with exactly one free variable, perhaps with many occurrences, may be thought of as a complex one-place predicate. To see how this works, let us translate formulas 1-4 into nearly colloquial English. E1x, he she respects everyone. E2x, he she respects someone. E3x, he she is respected by everyone. E4x, he she is respected by someone. Now, if we say of someone that he she respects everyone, then we are attributing a complex predicate to that person. We can abbreviate this complex predicate x, which stands for x respects everyone. Similarly with all the other formulas above. Each one corresponds to a complex predicate, which can be abbreviated by a single letter. These abbreviations may be summarized by the following schemes. xy or xy, bxy or xy, cxy rix, dxy rix here, basically means, is short for. Now, complex predicates can be used in sentences just like ordinary predicates. For example, we can say the following: some freshman is A, every freshman is B, no freshman is C, some freshman is not D. Recalling what A, B, C, and D are short for, these are read colloquially as follows. Some freshman respects everyone, every freshman respects someone or other, no freshman is respected by everyone, some freshman is not respected by someone or other. These have the following as overall symbolizations: xfx and xxfx, bxxfx and cxxfx and dx. But x, bx, cx, and dx are short for more complex formulas, which when substituted yield the following formulas: xfx and y or xy, xfx y or xy, xfx and y rix, xfx and y rix. We can also make the following claims: every A is B, every A is C, every A is D. Given what A, B, C, and D are short for, these read colloquially as follows: everyone who respects everyone respects someone, everyone who respects everyone is respected by everyone, everyone who respects everyone is respected by someone. The overall symbolizations of these sentences are given as follows: xx bx x x cx x dx dx. But x, bx, cx, and dx are short for more complex formulas, which when substituted yield the following formulas: xy or xy, y or xy, xy or xy, y rix, xy or xy, y rix. Let's now consider somewhat more complicated complex predicates, given as follows: xx respects every professor, bxx is respected by every student, cxx respects at least one professor, dxx is respected by at least one student. Given the symbolizations of the formulas to the right, we have the following abbreviations: xy pi r xy bxy psi rix, cxy pi and r xy dxy psi and rix. We can combine these complex predicates with simple predicates or with each other. The following are examples: 1. Some S is A, 2. Some P is B, 3. Every S is C, 4. Every P is D. The colloquial readings are: 1. There is a student who respects every professor, or 2. There is a professor who is respected by every student, or 3. Every student respects at least one professor, some professor or other, or 4. Every professor is respected by at least one student, some student or other. And the overall symbolizations are given as follows: O1 xsx and xo2 xpx and bxo3 xsx cxo4 xpx dx. But x, bx, cx, dx are short for more complex formulas, which when substituted yield the following formulas: f1 xsx and y pi r xy, f2 xpx and y psi rix, f3 xsx y pi and r xy, f4 xpx y psi and rix. These correspond to the formulas obtained by the technique of quantifier specification, presented in the previous section. The advantage of understanding complex predicates is that it allows us to combine the complex predicates into the same formula. The following are examples. XX respects every professor. BXX is respected by every student. CXX is respected by at least one professor. No A is B, every B is C. These may be read colloquially as no one who respects every professor is respected by every student. Everyone who is respected by every student is respected by at least one professor. The overall symbolizations are, respectively, XX and BXX, BXCX, but X, BX, and CX stand for more complex formulas, which when substituted yield the following formulas. XY pi r xy and y psi rix xy psi rix y pi and rix.